Hi everyone. Today let us we discuss the topic about concurrency controlling database management system. A concurrency control can access multiple users can access and use the same database at one time, which is known as a concurrent execution of the database, which ensures that database transactions are performed concurrently and accurately. It confirms that produce correct results without violating data integrity of a respective database. So let us discuss some examples. So now two people buy a movie ticket for the same movie and at the same show time. But there is only one seat is left for the movie show in that particular date. Here the concurrency problem will occur. Here what we can do, how can we solve these problems without concurrency control? It is not possible to buy ticket. For this, based on the first come first out priority, it provides ticket to the buyer who has completed the transaction process first. This is about who has completed the process first, then they have the ticket. So this is about the concurrency control. So let us discuss what are all the problems in concurrency control. The first problem is lost update problem, which is called WW problem. It occurs when multiple transactions select the same row and update the row based on the value selected. Here we have C with an example. Here the value of A equal to 100. Here we have done two transactions, transaction 1 and transaction 2. Here the first user done a transaction 1. Here a equal to a minus 50. Here the value of a equal to 100. 100 minus 50. Here a value equal to 50. This is final value when transaction 1 is done. After the transaction 2, the another users update the same row. Here R A equal to A plus 100. Here the A value equal to 100. 100 plus 100, 200. In this regards, before the value is read, the value is not right. So here the transaction 2 uses the same value in the given database. Here that this is the lost update problem. And the next one is dirty read problem. When one transaction updates an item of the database and somehow the transaction fails and before the data gets rolled back, the updated database item is accessed by another transaction. Here we have seen an example. Here the A value equal to 100. Here the transaction T1 or A read of A. Here the value read of A equal to 100. Here A equal to A plus 50. Here 100 plus 50. Here A value equal to 150. After that reading A value, here now the right of A equal to W of A. Here what is the value? W of 150. And the next transaction to the next another users access this database. Read of A. Here the read of value A equal to 150 because here the value is right. Before after that reading process, write process also done. So here the read of A value equal to 150. Here the transaction is getting failed and it get rolled back to the transaction one from the first process itself. So this is called a dirty read problem. And the third one is unrepeatable read problem. It is also known as inconsistent retrievals problem that occurs when in transaction. Two different values are read for the same database item. Here we have see the example. A equal to 100. Transaction 1 read of A. A equal to 100. Here only the reading process is occurred, no write problems is done. So after the transaction 2, read of A, here the R A value equal to 100, A equal to A plus 100, 100 plus 100, A equal to 200. So the write of A equal to 200. After that the Another user done the transaction 1. Here the read of A value equal to 200 because here we have done the write of A problem. So this is called a unrepeatable read problem. So these are the problems occurs in the concurrency control. And next, what are all the need for concurrency? So here what are the basic needs we have to maintain the concurrency is maintaining database consistency. What does mean by consistency? There should be a no duplications or any other false or awkward. So this is all maintaining database consistency and preserving transaction isolation. Transaction isolation, which means separation. So the each and every transaction when done in has been done in a single manner. And then preventing common anomalies, which means error occurs. So prevent some third parties errors and handling deadlocks and starvation and ensuring serializability. So these are the need for concurrency. And types of serial schedules. There are two types of serializable. One is conflict serializable and another one is view serializable. So here we have see conflict serializable. Conflict serializable ensures that a concurrent schedule gives the same result as some serial execution by reordering non-conflicting operations. This helps maintain data consistency. It is stricter than view serializability, which allows more flexibility but still preserves correctness. Two operations from different transactions are said to be in conflict when they access the same data item and at least one of them performs a write. The conflicts can be categorized into three types: read write conflict, write read conflict, write write conflict. From the read write conflict, one transaction reads a data item while another writes to it. And write read or conflicts, one transaction writes a data item while another reads. From write conflicts, both transaction attempts to write the same data items. So let us be discuss in detail with an example. So we have seen transaction 1 and transaction 2. Here in this first read operation also done, write operation also done. Here we also done a read operation and read and write. Here the read of A, write of A. Here also read of A, write of A, read of B, write of B, and read of B, write of B. Here the both actions are performed. So this is called conflict serializability. So next, view serializability. View serializability is based on the concept of view equivalence between schedules. Two schedules are said to be view equivalent if they satisfy the following condition. There should be a conditions: initial read condition, read from condition, final write condition. Initial read condition means for every data item Q, if a transaction Ti reads the initial value of Q in schedule S, then in schedule S1, transaction Ti must also read the initial value of Q. Then read from condition. For each data item Q, if a transaction Ti reads the value of Q that was written by another transaction Tj in schedule S, then in schedule S1, the transaction Ti must also read the value of Q produced by the same transaction Tj. And final write condition here, for every data item Q, the transaction that performs the last write on Q in schedule says must also be the one that does the final write in the schedule S1. Here we have see one example. So in transaction T1, the both read of A and write of A, read of B and write of B. Both different data items are read and write at the same time. In transaction T2 also, both data items are performed at the different and read and write operations. The data queue items are in the simpler manner. So these are the concurrency control and what are all the serializable types of discussed in this video. Thank you.